So now we are going to discuss about definite integral as a limit sum. So the formula for integral a to b f of x dx, limit extending to infinity b minus a by n, summation r is equal to 1 to n f of a plus b minus a into r by n. So this is a formula if the integration is given in between a to b. So a to b f of x dx is equal to limit tending to infinity b minus a by n, summation r is equal to 1 to n f of a plus b minus a into r by n. Suppose if the limit is given as 0 to 1 f of x dx, here a will be 0 and b will be 1. So in this formula, if I am substituting a is equal to 1, a is equal to 0 and b is equal to 1, I will get limit n tending to infinity. So b is nothing but 1. 1 minus 0 is 1. So 1 by n. Summation r is equal to 1 to n. Here a is equal to 0 and b minus a is equal to 1. So if you substitute a answer as 0 and b answer as 1, you will get f of r by n. So if the limit is given as 0 to 1, you need to use this formula. Otherwise, this is a general formula where a is a lower limit and b is a upper limit. So exercise 9.2, the first problem, 0 to 1, 5x plus 4 into dx. So I want here, look at the limit. The limit is given as 0 to 1. So I am going to use the second formula. Integral 0 to 1 f of x dx is equal to limit n tending to infinity 1 by n summation r is equal to 1 to n f of r by n. Here f of x is given as 5x plus 4. F of x is given as 5x plus 4. So here I am going to substitute f of x as 5x plus 4 into dx. So limit n tending to infinity 1 by n summation r is equal to 1 to n f of r by n. I written the formula. Limit n tending to infinity 1 by n summation r is equal to 1 to n. So I am going to substitute wherever I have x, I need to substitute r by n. So here I have x. So instead of x, I need to substitute r by n. So 5 into r by n plus 4. So this summation is only for r. So other than r values and all, I am going to take it outside. Limit n tending to infinity 1 by n, 5 by n summation r is equal to 1 to n r plus summation r is equal to 1 to n 4. So so n into n square. So 5 by n square summation r is equal to 1 to n r plus, here if you give the limit, I am going to multiply with 1 by n this number and also this number. So 1 by n summation r is equal to 1 to n 4. So 5 by n square. This is summation 1 plus 2 plus 3 plus 4 plus up to n. So sum of n terms. So sum of n terms formula is n into n plus 1 by 2 plus 1 by n. So if you substitute r is equal to 1 to n, you will get 4n. So this n and this n can be cancelled. So this 2 I can multiply here. So 2 into n square into n I can multiply. So n into n square plus n plus 4. So here I am taking n square outside. So 2 by n square into, if I am taking n square outside, this will be 1 plus 1 by n plus 4. This n square and this n square can be cancelled. So 5 by 2 is the number I can take outside. No need to substitute the limit n tending to infinity. So I will get 1 plus 1 by n plus 4. Because this 4 is dependent on this n. So that I am writing separately. So 5 by 2 plus 1 plus 1 by infinity. 1 by infinity is 0. So 1 plus 0 I will get. So 1 plus 0 is 1. So 5 by 2 into 1 is 5 by 2 plus 4. So I am taking 2 as LCM. This will be 5 plus 4 2s are 8. So 13 by 2. So the answer is 13 by 2. So now I can verify with the as usual integration. So 0 to 1, 5x plus 4 into dx. So 5 is a constant. The integration of x dx is x square by 2 plus the integration of 4 dx is 4x. So first I want to substitute the upper limit and I want to substitute the lower limit. So if I substitute upper limit, I will get 5 into 1 by 2. That is 5 by 2 plus 4 into 1, 4. If I substitute the lower limit, I will get 0. Here I am substituting 0. Here also I am substituting 0. So 0 into anything is 0. So 5 by 2 plus 4. If you take LCM as 2, you will get 13 by 2. So my answer is correct.